Hey dudes, it's Mr. Post, and on tonight's video, the goal is for you to be able to calculate the pH of a solution from the OH concentration. This is the hydroxide ion concentration, expressed in molarity, and from that tonight, you need to say what the pH is. So the goal is for you to calculate the pH given the base concentration. We're going to do a few examples tonight, guys, so let's jump into it. Little background information. When I'm expressing something in these brackets here, I am expressing a concentration of that specific thing, and it's going to be expressed in molarity. And that's going to be moles per liter. So this is going to be my base concentration, my hydroxide ion concentration, but something new is this tonight. Okay, when I multiply my hydronium or H plus ion concentration by the hydroxide ion concentration, I will always end up with this number, 1 times 10 to the negative 14th. And that's huge. We're going to be using that a lot tonight, and so just get ready to use it, dudes. The steps necessary are 2. So in order to calculate the pH given my hydroxide or base concentration, I need 2 steps. The first is going to involve solving for the H plus ion concentration. Now I'm going to use this right here, guys, the brand new formula that I showed you. So if I give you this, if I give you that, and you also are given this, we're going to use a little bit of algebra to rearrange the equation to say the H plus ion concentration is going to be equal to 1 times 10 to the negative 14th divided by the hydroxide concentration. And that's going to be expressed in the problem. You'll have that number. Step 2 is going to now plug this value into my pH formula. Remember, the pH was the negative log of the H plus ion concentration. Once you have that number, you plug it in down here, and you're going to find yourself the pH. Also, viewers, check this out. When I mentioned H plus, I could also interchangeably be expressing the H3O plus ion concentration. They're often used in the same exact way. In our first example tonight, we see we are asked to calculate the pH of a solution, and the solution is a base. I have a hydroxide ending, the OH ending, and the hydroxide has a concentration of 3 times 10 to the second molar, negative second molar. Step 1 we're going to use, the same as before, is going to be to use my formula, the H plus concentration plus my OH, or hydroxide ion concentration, equals 1 times 10 to the negative 14th. That's always going to be, part of my first step. Is going to be use that equation to solve for my H plus ion concentration. When we rearrange this, as we saw before, the H ion concentration is going to be equal to 1 times 10 to the negative 14th divided by my hydroxide ion concentration, which the problem tells us is 3 times 10 to the negative second. Once I crunch those numbers of 1 times 10 to the negative 14th divided by 3 times 10 to the negative second, I find out that the hydrogen ion concentration is going to be equal to 3.33 times 10 to the negative 13th. So that is part 1. I kind of have my hydrogen ion concentration right now, right there. And that is really cool. Awesome part. I see that my exponent value is around 13. That means my pH, just a little, heads up, your pH should be around there. My pH is going to be between 12 and 13, most likely. That's what that exponent is going to give me a little heads up for. Step 2, we're going to use that ion concentration in my pH formula, because the pH of a solution is equal to the negative log of the hydrogen ion concentration. And when I substitute that previous value into this formula, and then take the negative log of that, we find out that the pH is going to be equal to 12.5. Excellent, dude. So once again, 2 steps are needed to solve this problem. Try the next problem on your own. See how you do. In this example, we're asked to calculate the pH of a solution of NaOH with a concentration of 3.5 times 10 to the negative fifth molar. So we're going to go with our two steps again. Step 1. Let's use the formula of the hydrogen ion concentration multiplied by the hydroxide ion concentration equals 1 times 10 to the negative 14th. Step 2, a little rearrangement as we always do. The H plus is going to be equal to 1 times 10 to the negative 14th divided by my hydroxide concentration of 3.5 times 10 to the negative fifth. And we solve the numbers and end up finding out that the hydrogen ion concentration is 2.86 times 10 to the negative 10th. Awesome, dudes. That's part 1 here. That's my first part of this one. Step number 2 is going to be to use the concentration in my pH formula. pH is the negative log of the H plus ion. So when we plug the number in, the pH is going to be equal to the negative log of 2.86 times 10 to the negative 10th. And our pH is going to have a value of 9.5. Once again, does that sound right? Yeah, it is. It's in the ballpark of that exponent. So my pH is 9.5. This is a basic solution. Alright, basic solution now. Anything over a pH of 7 would be considered a basic solution. Alright, dudes, let's try the next problem. In this problem, I'm throwing you a curveball. I want you to calculate the pH of a solution. Once again, I'm giving you the concentration of the base. But this time, the base has 2 hydroxide ions that are going to dissociate when it hits the water. So even though I give you the concentration of the base, you're going to need to double that to account for the doubling of the ions of hydroxide that will go into solution. Alright, dudes, same way as we always do. Let's use the concentration formula again. Let's plug in our values. H plus is going to be equal to 1 times 10 to the negative 14th divided by, in this case, check this out, dudes, you got to be really careful here. We're going to divide this by 2 times 4.5 times 10 to the negative 9th. And now I did that because there were 2 hydroxide ions. When we use that value, the hydrogen ion concentration in solution is 1.11 times 10 to the negative 6th. Awesome. That's part 1. We've gotten the concentration. That's essential for step 2. In step 2, we're using the pH formula. The pH equals the negative log of the H plus ion. Let's plug our values in, guys, and solve for the pH. And we end up finding the pH is going to be equal to 5.95. You know, once again, that's in the ballpark of my exponent right there, too. Alright, dudes, that's all the examples for tonight. I hope it was helpful. I hope it brought some clarity to this topic for you. Alright, man. Thanks a lot, guys, for tuning in. Have a good night. Peace.